Hello everyone. Welcome. I am Mayur Gohil. Today we will be solving this question which was there in one of the examinations in December 2022 in MU for 8 marks. So let me just mention here this is an 8 marks question. So let us see how to handle this kind of question in examination if it comes. Now this is pretty lengthy question, so be very careful and solve it, and let us see how to go about it. So the first thing is that whenever a system of equation is given to you, you break down the system into its matrix notation. So you try to write down that and try to classify the system carefully. So first we write in matrix notation. So in matrix notation, the above system is written as follows. So it will be, we will have to write the coefficients of x in the first column. So it is 2, 1, 1. Coefficients of y are 3k. Second is k plus 4. The next is 2 times bracket k plus 1. The next coefficients of z are 3k plus 4. They will come in the third column. Okay, so here it is 4k plus 2. Here it is 3k plus 4. Okay, now we have got these in the matrix notation. We write now the other x, y, z. Okay, and here the RHS is 0, 0, 0. Now here we note down the following things, that since RHS is a zero matrix of 3 rows and 1 column, the system is a homogeneous system. Okay, this is what we can note down. You need not write this in exam, but for your understanding purpose I am giving you this. Now what we do with this system, first of all, now homogeneous system always has a solution. Okay, so its solution by default is x, y, z equals to 0, 0, 0. But there is one very important thing they have mentioned in the question itself, that they want a non-trivial solution. Non-trivial solution meaning other than x, y, z being 0, we have to give them something else. So what values for k are there that other solution will happen? So let us see how to go about that. Now so we write down here the matrix A. This is the matrix given to us. Now what we do, we perform R1 interchange with R2. So we get here 1k plus 4, 4k plus 2 in the first row, and then there is 2k, sorry, 2, 3k, 3k plus 4 in the second row. Just the rows are interchanged, and here it is 3k plus 4. Okay, now what do we do? The next thing is we reduce this 2 and 1 that we see, this one and this one, to 0. Okay, we are converting our matrix to row echelon form as much as possible. Let us see how. So we will now perform R2 changing to R2 minus 2R1 and R3 changing to R3 minus R1. Okay, so let us see what happens. The first row remains unchanged. Okay, so that is 4k plus 2, that will remain as it is. Now 2 times 1, when you do, you will get 2, and that we have to subtract, so it is 0 over here. Now 3k minus 2 times k plus 4. Okay, so I'll just do this thing in rough over here. So it is 3k minus 2 times k plus 4. So that is 3k minus 2k minus 8. So this is k minus 8 is the answer here. Okay. So this is k minus 8. The next one, what we have to do is 3k plus 4 minus 2 times 4k plus, what is that, 4k plus 2. So what will we get is 3k plus 4 minus 8k minus 4. So this 4 and 4 gets cancelled, I get minus 5k. So this is minus 5k. That is what I get. Alright. Now the next part here is 1 minus, so R3 minus R1. When we do R3 minus R1, we will get here 0, right? That is what we will be getting. So here we get 0. And now let us see what happens there. 2k plus 2 minus k plus 4. Okay, so minus is there, so be very careful, put a bracket and then do. So 2k minus k plus 2 minus 4, so it is k minus 2. Okay, I get k minus 2 here. The next part is 3k plus 4 and minus 4k minus 2. That is what, when you subtract, you will get. So that is minus of k plus of 2. Okay, so we get minus k plus 2. Okay, so this is the matrix that we get after trying to bring the matrix in a row echelon form. Okay, so this is what we are getting here. Now we cannot do further calculations after this. Now comes the analysis part and the understanding part. So let us see what all things we can understand from whatever we have concluded and whatever we have learned. Here, what is it asked? We want a non-trivial solution, right? And the system is a homogeneous system. So here first thing we write. Okay, so now we write here. Here the system has three unknowns. Therefore, n is equal to 3. Okay. Now, system is homogeneous, so it has non-trivial solution if rank of A is less than 3. This is what is the thing. Now comes the choices for rank. Therefore, what are the choices for rank A? Rank A can be either 1 or 2. It has to be strictly less than 3. Okay, if it is equal to 3, then it will become, what the answer will be there, it will be trivial solution, which we don't want. We want non-trivial solution. So that means that implies rank A is 2 or 1. So we have now two cases. Case 1. Case 1 will be when rank of A is 2. What will happen? Let us see. Now when rank of A is 2, we know that there is, which means that there exists a submatrix M 2 cross 2 such that determinant of this submatrix 2 cross 2 is not equal to 0. So now comes our biggest task, that we will have to find all possible 2 cross 2 matrices for this matrix A. So let us see how to find that. Now we had our matrix A reduced to the form of, okay, now what we have to do, let us see. So we find all possible submatrices M11. Let us see. M11 is K minus 8, K minus 2, minus 5K, minus K plus 2. Okay, this is what is there. Now let us see M12. M12 will be the matrix that we obtain by deleting the first row and the second column. So first row is deleted and the second column is deleted. So then it is just 0 0 minus 5k minus k plus 2. Okay. M13 will be delete first row and the third column. So again it is 0 0 k minus 8 k minus 2. Then we will have M1 M21, so it is delete second row and first column. So you have here k plus 4, k minus 2, and then there is 4k plus 2, and here it is minus k plus 2. Okay, then again like this we go on finding all the possible matrices. This is what we get. Now for each of the matrix we will calculate the determinant. So now the easy ones we will do first. Let's see. M12 is very easy. The determinant of this is 0. Determinant of M12 is 0, and this is not allowed. Why? Because we have already written such that the determinant of 2 cross 2 is non-zero, so this is discarded. So discard M2, M12. Okay, so this case is discarded. We just write here M12 is discarded. Similarly, we see that M13 is discarded. That is also not to be taken into consideration. Now let us calculate the remaining determinants. So for the first one, let us see how to calculate the determinant. So here when we calculate the determinant of M11, M11 determinant is not equal to 0. We have to calculate it. Let us see what value for k we will get. So that will be k minus 8 multiplied by minus of k plus 2 minus of minus 5k, right? Minus of minus 5k times k minus 2 equal to 0. So when we simplify this, we will get k minus 8 into k minus 2 into minus of 5k into k minus 2 equal to 0. I have taken minus sign common from each term, so it is gone away. So now here you can see k minus 2, and then k minus 2 can be taken common, so it is k minus 8 minus 5k equal to 0. So what we get here is k minus 2 equal to 0, or here it is it will be minus 8 minus 4k equal to 0. So k is equal to, uh, we have not equal, right? So it will be not equal here all throughout. So k is not equal to 2, or here it will be k, here it is 4k not equal to -8. So k is not equal to -2. So therefore from case number 1, M11, when the determinant is not equal to 0, we get k is not equal to ±2. This is what we get. So this is what you need to consider in the first case. Now again we see the other cases and we come to the conclusion. So this is how this sum is built up. So for the first, M12 is gone, M13 is gone because we discarded them, because the determinant is equal to 0 in this case. Okay, now let us see for the next one. So determinant M21 is not equal to 0. So this is going to happen. Then what will happen here? We will see k plus 4 times minus of k plus 2 minus 4k plus 2 times k minus 2 is not equal to 0. So what we get is minus taken common, k plus 4, k minus 2, and here it is minus 4k plus 2, k minus 2 not equal to 0. I can shift away the minus sign, and we can take minus k minus 2 common, and here we get k plus 4. Okay, and here it will be plus 4k plus 2 not equal to 0. So this will be k minus 2 not equal to 0, or here we will have 5k plus 6 not equal to 0. So this will be k is not equal to 2, or k is not equal to minus of 6 by 5. In this case we get this another answer also. Now let us see what other answers are possible. We also had, so for this case we get k is not equal to 2 and minus 6k by 5. Now let us see what other values k can take. In M22 not equal to 0, determinant, if determinant M22 is not equal to 0, that means if we take the determinant of this, it is minus of k plus 2, which is not equal to 0, which implies that k is minus k is not equal to minus 2, implying k is not equal to 2. That possibility we have already found out. Again from the second case, determinant here M23, when it is not equal to 0, we have found out that k minus 2 is not equal to 0, so this implies that k is not equal to 2. Again this possibility is gone. The next case is this M31. Okay, for M31 we will need to find, let us see what happens there. Now M31 is, so determinant M31 not equal to 0 implies that k plus 4 times minus of 5k minus of k minus 8 into 4k plus 2. is not equal to 0. So let us simplify this quadratic equation. So it will be minus of 5k square minus of 20 minus of 4k square minus of 32k plus 2k minus of 16 not equal to 0. Okay, so let us uh, simplify further. And okay, so here we have this, and this is a quadratic that we will need to solve. When you solve this quadratic, you get this as the answer. Now let us see the other case. So in this case, here it is determinant of m32 is not equal to 0. Determinant of m32 is not equal to 0 implies minus of 5k is not equal to 0. It implies that k is not equal to 0 in that case. Okay, and here determinant of m33 is not equal to 0. This also means that k plus 8 is not equal to 0. It means k cannot take the value minus 8. So now from this answer we have got pretty many solutions for k, that k cannot take what all values. So let us sum it up carefully. So k cannot take plus and minus 2. Okay, also it was from the case number m11, right? Now in the next case what we got was k cannot take the value minus 6 by 5. The next thing what we got here is k cannot take values 2. We also found k cannot take value plus 5 times plus minus root of 21 divided by 3. K cannot even take the value 0 and minus 8. Okay, 0 and minus 8 when the rank is 2. So this is what is the all possible values. So k is allowed to take, if k is real number, then k belongs to all those real numbers. K can take all those real numbers which are not 2, minus 2, minus 6 by 5, 5 plus root 21 by 3, 0 and minus 8. This is what is the solution for k. This is what is required. Okay, so these are the possible values for k. Can take all the values other than these. Okay, I hope you have understood this case. Now let us go for the next case. Here in this case 2, see case 2 is slightly difficult and very important to understand. When rank of a is 1, now we have to understand whether the rank a will be 1 or not. We have, by theoretical practice, we came to know that rank of a can be 1. Okay, that is what we have got, but we have to see for what value for k that simultaneously everything becomes satisfied. So let me write down the matrix first, and let us understand the argument over here. The argument for this question is slightly tricky. I am going to say here that rank rank of a is never 1. Okay, is never 1. Okay, this is my claim here. We will show by simple argument. Suppose that Suppose that rank A is 1. Then, then by row echelon form definition, second row and third row must be 0 rows. Okay, we need, therefore we need a value of k such that k minus 8 is equal to 0, minus 5k equals to 0, k minus 2 is equal to 0, and minus k plus 2 is equal to 0 together. Okay, together, which is not possible. But this is not possible because k is equal to 8, k is equal to 0 from the second equation, k is equals to 2, and k is equals to again 2, right? So these three values together we are getting, which is, but this is not possible as k is 8, 0, and yeah. Hence k, hence rank of A is not equal to 1. So case 2 does not uh, exist. This is the solution for the entire answer. This was pretty lengthy and a tough question which was asked in examination. So let us go through the entire question again carefully and understand what all things are there while solving such a kind of a question. Whenever we get such a question to solve, firstly understand that for what values we have this k. You write down the system and try to reduce it to row echelon form. Row echelon form as such it won't be visible, but you can try to bring it into the most nearest possible form of row echelon. So I have tried to bring it over here. This is the most nearest I can go to the row echelon form, that first element a11 is non-zero, below it every element is 0, right? That is what I have done. Further, it is not possible to make any element 0 or anything like that. Now, what else we can do? Then we start our analysis. The analysis of a system being a homogeneous system, what happens here? Here we see that system has three unknowns, and there are, the system is a homogeneous system. It has a non-trivial solution when the rank of A is less than 3, and the that gives me two cases: either the rank of A is 2 or the rank of A is 1. So when rank of A is 2, it means that there is a submatrix whose order is 2 cross 2 such that its determinant has to be non-zero. So we find out all possible cases over here. So here there are 9 such submatrices that can be obtained. So we write down those 9 such matrices. So those 9 matrices are here. This is I'll write here those 9 matrices are. This is the first matrix M11, M22, the second matrix. This is the third matrix. This is the fourth matrix. M22 is the fifth matrix. M23 is the sixth. M31 is the seventh matrix. M32 the eighth one, and M33 the ninth matrix. Okay, so these are the 9 matrices that we obtain. For each of the 9 matrices, we say that the determinant is non-zero. So when we calculate for the first matrix, determinant is non-zero. When we say, we observe here that minus sign and all that is there, we calculate for the value of k, and this determinant being not equal to 0, we get the value for k is plus or minus 2. That so k cannot be equal to plus minus 2. For the second case, we immediately observe, because one column is 0, the determinant is going to be 0. Here also M13 we see that one column entire entries are 0, so M13 and M12 cases are discarded. For M21, when we solved, we get a quadratic and we see that k is not equal to 2, or it is not equal to minus 6 by 5. Okay, we get that equation and we get the answer as k is not equal to 2 and k is not equal to minus 6 by 5. This is the case that we got. Okay, so that is what we get. Then similarly we go for M22, M33. We get there k is not equal to 2. Each time we get k is not equal to 2, but there is a real number existing in between in each cases that we have to go for. Now when we go for M31, what do we observe? That for M31 again we get a quadratic equation, which is not so nice as the previous ones. We simplify this quadratic equation and we get that k value cannot be equal to, here we write here that k is not equal to 5 plus minus root of 21 upon 3. K cannot take this number. Okay, so this is what we get, k cannot take this value. Now when we simplify further, we get M32, k cannot be 0 also. Okay, that is what is that there. And here in the last case we get k is not equal to minus 8. Having said that, we go for summarizing our answer, that k cannot take what all values. K cannot take value 2, cannot take value minus 6, k cannot take. We now summarize our answer and say that k cannot take value plus minus 2 minus 6 by 5, 5 plus minus root of 21 upon 3, 0 and minus 8. These all values k cannot take. Then what values k can take? All other values other than this. So real number minus these numbers that we found, k can take all other numbers other than these numbers that we have found. Okay, this completes half part of your answer, and it was truly tough task for you to find all the cases and get these answers. Now comes the next case, the last case, rank A equal to 1. This is a tricky case which generally you have to handle very smartly. Rank A equal to 1 means what? It means that you have a submatrix whose order is going to be 1 cross 1 and its determinant is non-zero. So that we can clearly see that here there is a submatrix over here in this, the first entry A11, which is non-zero. But what about the other entries? They are all they 0? If they all are 0, they have to be simultaneously 0. So we discard the first row because in row echelon form, what is the definition? At least one row should be non-zero and all other rows should be zero rows, they are below it, right, below the main row. So in row echelon form, when we have that definition, the if the rank of a matrix is 1, that means all other rows below it are 0. So second row and third row must be 0. It means that k minus 8 minus 5k, k minus 2 minus k plus 2, all of them have to be 0 together. So if we simplify this, what do we get? K is 8, k is 0, k is 2, all together. Now, k can take only one single value at a time. It cannot take all values at a time. So this means that rank uh, of A cannot be 1. Okay. So the case number 2, which was emerging when we had argued that rank of A is less than 3. So there are two possibilities. Either it is 2 or it is 1. So there is a possibility that rank A can be 1. We have entirely uprooted that possibility by this argument given over here, that rank of A cannot be 1. Okay, so case 2 will not even formulate. Even if you formulate, then you have to give us very strong argument, and this is very strong argument over here that rank of A will not be 1. Okay, so this is the solution for this question which was there in the examination for 8 marks. None of the textbooks which are available would give you this kind of detailed argument for these kind of questions, because they have a very standard rudimentary style of giving that. But this is how you give an argument to the question to solve it carefully. Okay, so I hope you understand the details of this kind of solution. Attempt these kind of solutions very carefully. It was for 8 marks and so slightly tricky for students to attempt. So let us see similar questions in the next video lecture. Already this has been a very long video, so I hope you understand this question. I hope you liked it. Please hit like button and share it with your friends. Thank you.